So let's do exercise 1.2. Okay, the first is sum, where they are saying the function where r star is related to r star, which means the domain, this is the domain and this is the codomain, the domain part and the codomain part. This is the domain and this is the codomain. Domain means all values of x-axis and codomain means all values of y-axis. It says r star, where r star indicates non-zero real number. Simply because the fact that this question is f of x is equal to 1 by x, you know that x cannot be equal to 0. That's the reason why they've specified it as non-zero real number. Okay, so that explains why it's a non-zero real number. You have to prove that this is 1 to 1 and on to. So non-zero real number may be anything, if it's 2 then it will become 1 by 2, if it's minus 2 it will become minus 1 by 2. Okay, you can do a reciprocal function graph. This is f of x equal to 1 by x. When x is 1, y is 1. Okay, when x is 2, y is 1 by 2. When x is 3, y is 1 by 3. The graph is like this. Okay, and when x is 1 by 2, y will be 2. So then the graph will go on like this. And this is what, and for negative ones it's like this, and this is the reciprocal function graph. And as you see, for every other than 0, because this anyway x is not equal to 0, every point on x will have a unique value of y. Can you see? You should know to interpret a graph. This is all 8th standard portions to interpret graphs. So then therefore it's definitely 1 to 1. So as soon as you see this graph, you know that this function, reciprocal function, is 1 to 1. Okay. So theoretically, how do we prove? Theoretically, we know that for the fact that this is definitely 1 to 1 from the graph. I also given 2 examples of the domain and the codomain where it is working out to be 1 to 1. Theoretically, how do we explain that? Theoretical part is you have to assume that is many to 1. Assume it's many to 1, where you're going to say f of x1 is equal to f of x2. Which means in the domain, you're considering 2 different things, x1 and x2, and you're trying to say that both of them are related to one y value. So f of x1 is equal to f of x2, which is called many to 1. So assuming the converse, which is many to 1, and substituting that in the question, this is the question. So 1 by x1, the function is 1 by x1 is equal to 1 by x2, which shows that x1 is equal to x2, therefore it's 1 to 1. So this is the theoretical way of saying it. And this is a normal graphical way of explaining, and with the diagram of domain and codomain. Okay, how to explain its onto? I've told you what is onto. Onto functions are those which do not, where the codomain, every element of the codomain has a pre-image, And obviously, from the graph, it's also onto. It's definitely onto. It's 1 to 1 as well as onto, because every element on the y-axis has an element on the x-axis mapped to it. So it's 1 to 1 as well as onto. But theoretically, how do we prove it's onto? The theoretical way of saying it is, that f of x is equal to 1 by x is the question. Write it as y is equal to 1 by x. Therefore, x will be 1 by y. And x itself is nothing but f inverse of y. I've told you already in the class that the downward function is f of x is equal to y. The reverse function will be f inverse of y is equal to x. The fact that you got an x here shows that this is f inverse of y. Okay, now this is the condition. So this is the condition for it to be onto. Now take this f of x. But what is x? X you found out to be 1 by y. And substitute this in the given function. What is the given function? 1 by x, right? The given function is 1 by x. So if f of x is equal to 1 by x, f of 1 by y will be 1 by y, and therefore the answer is y. And so then thus you got f of x to be equal to y, and f inverse of y is equal to x. These two confirms that theoretically this is an onto function. But however, graphically itself, it's very simple, but both these you should know. So there is a second part in this question, where the second part they are asking you to relate the natural number to r star, where the domain is a natural number. The natural numbers are 1, 2, 3, 4, 5, etc. And r star is every non-zero real number, which includes all the y-axis other than 0. So if you're going to reciprocal 1, you'll get 1, 2 means you get 1 by 2, 3 means you get 1 by 3, 4 means you get 1 by 4. From the fact, if you're going to do this graph, even if it's only natural number, so it's only a first quadrant. There's no negatives because the x values that you domain is the x values that you give, and they are all only positive values. So it's 1, it's 1. If it's 2, it's 1 by 2. 3, it's 1 by 3. And see, the graph itself starts from here and goes like this only. Whereas the y-axis has got every other element which do not have a pre-image. All these elements do not have a pre-image. All the negative elements of y-axis do not have a pre-image. So that shows that it's definitely 1 to 1. We can say that definitely it's 1 to 1 because every value has a unique value. X-axis has a value of y. It is definitely 1 to 1. But however, it is not on 2. And how do you explain? From the graph, you see that all these points which is above 1, above 1. So anything which is greater, when y is greater than 1, do not have a pre-image. Not only that, even all the negative values of y, that is when y is less than 0, have no pre-image, which concludes that this is definitely not onto, it's only 1 to 1. So this is the way you should explain. Normally these questions are not asked in board exams, but it's for your thinking process. Okay, I hope you all understood. Imagine if this is 1, you get value as 1. If it is 2, it will become 1 by 2, which is less. If it's 3, it becomes 1 by 3. And so the graph is going on like this. Okay, so that shows there's no graph above 1. There's no graph here at all. Can you see? So any points above 1 on the y-axis do not have a pre-image. You don't have a corresponding y to it. You can so then that's about it. So let's go to the second question. The second question is f of natural number to natural number, where f of x is equal to x square. It is a quadratic function. It's natural number to natural number, so such as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and so on. This is the domain. This is the domain in this natural number, and this is the codomain. And you can see from here that it's a quadratic function. So 1 is going to be mapped to 1, 2 is going to be mapped to 4, 3 is going to be mapped to 9, 4 is going to be mapped to 16. So what about the numbers in the natural numbers on the right side in the codomain, such as 2, 3, 5, 6, 7? They do not have a pre-image. They are also natural numbers. So the numbers such as only the square numbers such as 1, 4, 9, 25, 1, 4, 9, 16, 25, all these square numbers only have a pre-image. The non-square numbers such as 2, 3, 5, 6, 7, ... do not have a pre-image, which clearly suggests that it's definitely not on 2. Correct? It's definitely not on 2. Is it 1 to 1? Yes, from this mapping itself you can see 1 is related to 1, a 2 is related to 4, a 3 is related to 9, a 4 is related to 16, ... You can close it. This definitely shows that it's definitely 1 to 1, but it is not on 2. Supposing the theoretical way of explaining it, you know the solution, it's 1 to 1, but it is not on 2. How do you theoretically explain that? Let's assume that f of x1 is equal to f of x2. The function here is a quadratic function, so x1 square is equal to x2 square. x1 square minus x2 square is equal to 0. x1 minus x2 into x1 plus x2 is equal to 0. These are natural numbers. x1 is a natural number, x2 is a natural number. Adding to natural number will never be equal to 0. Therefore, x1 minus x2 can be equal to 0. You should specifically say this in your answer sheet. x1 is an element, x1 comma x2 or an element of natural number, adding them is never equal to 0. Therefore, the other term can be 0. Therefore, x1 is equal to x2, which concludes that's 1 to 1. How about on 2? On 2, always you should write f of x is equal to y f of x is equal to x square here, x square, but f of x is nothing but y. So instead write y is equal to x square, right? What is x? X is root y. X is root y, and but you know it is not onto, right? You know it's not onto. So then take f of x, where x itself is f of root y, and substituting it in the question, f of x is x square means f of root y will be root y the whole square, which will just be y. You're getting it to be like onto, but you know it's not onto. So you should write it. This is not going to work out. This is not going to work out for you. You know that the elements, the square numbers definitely do not have pre-image. Therefore, you should just write this is not valid. Therefore, this is not true. Not true. The square number, the non-square numbers, the non-square numbers do not have pre-image. So it's not possible for you to prove this theoretically, because if you prove it theoretically, you're getting f of x is equal to y, and you're not supposed to get it, correct? So then just don't write all this. You understand that theoretically is working out like this, so you know that generally you can write it with the numbers itself and leave it like that. You don't have to go to theoretical part for onto, because theoretical part for not onto is not working out. So let's go to the second part, second subdivision. The same question, second subdivision. Integer to integer, and it's the same f of x is equal to x square. The moment it is integer to integer, you know integer means even negative numbers will come, -3, -2, -1, 0, 1, 2, 3, 4, etc. Here also -3, -2, -1, 0, 1, 2, 3, 4, etc. -3 is also related to 9, 3 is also related to 9 when you square it. -2 is also related to, -2 is also related to 4. 2 is also related to 4. The moment you see this, it is definitely many to 1. This graph of domain, which is an integer, and a codomain, which is also an element of integer, very clearly in a quadratic function shows that it's many to 1. A good enough example, you can write it in ordered pairs also. In -3 is also related to 9, 3 is also related to 9. Therefore, it is not injective, it is not injective, or it is not 1 to 1. That's it. Supposing they tell you to do it, okay, and so injective is over. Well, let's look at onto. You know that so square numbers will always be positive. All these negative numbers will not even have a pre-image. The elements such as -3, -2, -1, and similarly even other numbers such as 2 will not have a pre-image. 2, the non-square numbers basically again, and all sorts of non-square numbers will not have a pre-image, correct? Will not have pre-image. So it is definitely not onto, or not surjective, So this is a natural way of writing, which is what is given in all the websites. But in case they ask you to prove that it's not onto, you leave it. When it is not onto, you don't have to prove it theoretically. Theoretically, if you're going to prove it's not 1 to 1, you know f of x1 is equal to f of x2. x1 square is equal to x2 square. x1 square minus x2 square is equal to 0. x1 plus x2 into x1 minus x2 is equal to 0 in an integer. An integer plus an integer can become 0. Therefore, I am not able to justify that this can become 0. Only if one becomes 0, one does not become 0, the other can become 0. But this itself can become 0. No? So I am not able to justify that this will be 0. So therefore, not 1 to 1. And regarding onto, they will never ask you to prove with alphabets. Not onto is always done with numbers. So you don't have to really bother, even though I have written in that paper, in the PDF, previous PDF, you don't have to worry. F of real number to real number. F of x is equal to x square. Real number means all numbers, even 1 by 2, minus 1 by 2. everything. So the domain is real number, the codomain is also real number to real number. Again the same thing, you can take -2 is related to 4, 2 is also related to 4. This is good enough example for you to say it's definitely only many to one. It is not one to one, not one to one. Finished. And also the negative numbers such as -2, -3 and all will not have a pre-image, -2, -3 etc. in the codomain. Not only that, and even non-square numbers, will not have a pre-image, That's all. So then definitely it is also not onto. Simply justifying with numbers would do. However, if they ask you to say it, the same explanation that we gave here in the previous case is good enough, because it's anyway not one to one only. The same thing, the same explanation can be written for this sum also. So let's go to next question, which is the fourth subdivision. A function where its natural number is related to natural number, f of x is equal to x cube. It's a cubical function, right? Natural number, if it's 1, the answer is 1. If it's 2, it will be 8. If 2 cube. Minus 1, I can't include, because the domain is also a natural number. That is, x-axis is also a natural number. So I don't have to look at the negative side itself. Okay, the graph is only so much. It's only this. And if you see 1 is related to 1, 2 is related to 8. What about these numbers 2, 3, 4? They don't have a pre-image, correct? And it's definitely 1 to 1. As you can see, 1 is related to 1, 2 is related to 8. So 1 is related to 1, 2 is related to 8, 3 is related to 27 and so on. Yeah, it's definitely 1 to 1. But not on 2. Not on 2. The reason being, the elements such as in the y-axis 2, 3, 4, 5, etc. do not have a pre-image. Do not have a pre-image. So that completes it. It's very simple. However, it's 1 to 1, right? There is 1 to 1. So supposing they ask you to do it theoretically, so you'll write f of x1. F of x1 is equal to f of x2. Supposing they ask you to write x1 cube is equal to x2 cube. x1 cube minus x2 cube is equal to 0. A cube minus b cube is a minus b into a square plus ab plus b square. You know this formula? These are the numbers which are natural numbers, and natural numbers will never be addition, will never be equal to 0, and therefore this can become equal to 0, and that shows that x1 is equal to x2. Onto is not onto, so that examples is good enough when it is not onto. Okay, are you clear? So let's go to the fifth question. F of integer to integer, f of x is equal to x cube. See, integer means even negative numbers are there. This -1 will become -1, -2 will become -8, 1 will become 1, 2 will become 8, and this is an ogive. That's the graph that you'll get, and you have 8, you have 1, you have -1 and -8 and so on. So what about the other numbers in the graph? These are all integers only. No, they do not have a pre-image. It's definitely 1 to 1, because the ordered pair is like this. If you have -2, the -2 is related to -8. -2 is related to -8. A -1 is related to -1. A 0 is related to 0. A 2 is related to 8. So it's definitely 1 to 1, no doubt. But not on 2. You list out these elements such as 2, 3, 4, 5, 6, non-cubical numbers, basically non-cubical numbers on the y-axis. On the y-axis or on the codomain do not have pre-image. So this is good enough for you to justify it, and 1 to 1 is the same as this. The same thing to justify it's 1 to 1 is enough. But is it 1 to 1? Definitely, yeah, it is 1 to 1. It is 1 to 1, but with the numbers is good enough. Okay, I don't think they would ask you with a justification using anything else. So that's enough. Okay, so third question. The question is f of x is equal to greatest integer function of x. It's from real number to real number, which is the domain is also real number. Real numbers include fractions, everything, decimal numbers or negative numbers and everything. And the greatest integer function, let's do the greatest integer function graph again. 0, 1, 2, 3, and it's 1, 2, 3, 4, and it's a real number, so I need to do the negative side. -1, -2, -3, -1, -2, -3. And the graph is fill, don't fill, fill, don't fill, fill, don't fill, and it goes like this, and fill and don't fill. This is the graph, right? And what are they asking you to do is to find whether that real, it's neither 1 to 1, it's definitely not 1 to 1. Take this part alone. X is inclusive of 0 till 1, every decimal number, the y value is always 0. The corresponding y value, just map it to y axis. Can you see it's only 0? Similarly, take the second line, this one. Let's look at this one. Let's look at this one. So when x is lying between, the purple color one, x is lying between 1 inclusive to 2 non-inclusive, the corresponding y value, map it to y axis, you get y is equal to 1. So all these numbers such as 1.2, 1.3, 1.4 and all has only an answer as 1. So when you write an ordered pair, it's 1.1, 1.4 is related to 1, 1.3 is related to 1, 1.2 is related to 1. So it's obviously many to 1. It can be 1 to 1. Only the question is about integer to integer. The same question was integer to integer. It can be 1 to 1. Then it's only integers you have to take. These decimal numbers will not even come into play. So I hope you understood. And what about onto? It's definitely not onto. Why? What about, this is real numbers, right? These are real number to real number. So what about these points in between? These small decimal numbers that comes in all decimal numbers on y-axis will not have a pre-image. So it's not onto, basically because this talks about real number to real number. It was integer to integer, it can be 1 to 1 here, okay? And it can also be onto. I hope you understood this part. So you have to read the question well to understand in a greatest integer function if the question is for real number to real number or is just integer to integer. Integer to integer, no problem. It will be 1 to 1 as well as onto. I hope you all understood. Let's go to next question. The fourth question. The fourth question is, again it's from real number to real number, where f of x is equal to mod x. Real number to real number, you know mod graph, right? The mod graph, 1 means 1, 2 means 2, -1 also 1. So the graph is like this, this mod function, the negative numbers will also get you positive y only. Correct? So it's many to 1. As soon as you see this graph, on real number to real number, it was natural number to natural number, no problem. Then there's only first quadrant graph which will come. So then therefore it is many to 1. Why is it many to 1? -2 is also related to 2. 2 is also related to 2. The fact that -2 and 2 are mapped to only 2 shows that it is many to 1. The graph also explains it is many to 1. And a real number, the y-axis is a complete real number which includes all the negative y, and you will not have any negative values in modulus functions. Correct? All negative elements on y-axis will not have pre-image. Can you see all this does not even have a graph. The negative elements on the y-axis do not even have a graph, do not have a pre-image, so it's not onto. Such an explanation is enough. You don't have to really look at it theoretically, but I just wanted you to understand how is it done theoretically, so that if your teachers are talking about it, you still understand, okay? So, fifth question. The moment they give me f of x is equal to 1, 0 and -1, when if x is greater than 0 and if x is equal to 0 and x is less than 0, 1 and -1 shows that it's a signum function. It's +1 and -1. I understand that this is f of x is equal to mod x by x. Moment I see this function, I know this is this. And as soon as you see, when all values of positive x is related to only 1, and all values of negative x is related to only -1, so it's definitely many to 1. So for all elements which are positive x elements, positive x axis are related to y being 1. Negative x-axis are related to y being minus 1. Therefore, it is definitely many to 1, it's not 1 to 1. Let's check if it's on to. It is not on to. Why? Because look at this, what about this is all these elements such as, is it on real number to real number again? Yes, this is again on real number to real number where entire y-axis and x-axis are there. So what about these decimal numbers other than 1 and minus 1? All real number other than minus 1 and plus 1 and of course 0, 0 and plus 1 do not have pre-image. Okay, are you clear? So therefore it is not onto. Such an explanation is good enough. You don't have to bother writing more. You know when it's greater than 0, it's x by x, so answer is 1 here. It's minus x by x, the answer is minus 1 here. The mod function defining, which I taught you in the class. So let's go to 6th question. Let's go to 6th question. 6th question, they've given a is equal to 1, 2, 3. B is equal to 4, 5, 6, 7. They have mapped it. 1 is related to 4, 2 is related to 5, 3 is related to 6. It's given in the question. So this shows it's definitely 1 to 1. Each one is mapped to 1. But 7 is orphan. 7 in the codomain. This is domain. A is domain. A is domain and B is codomain. A 1, 2, 3 here and a 4, 5, 6, 7. 1 is related to 4. A 2 is related to 5. A 3 is related to 6. But 7 is an orphan. So 7. So it's definitely 1 to 1. But 7 do not. 7 in the codomain. 7 in the y-axis. Y-axis or codomain do not have pre-image. That's all. Which shows that it's not onto. Such an explanation is enough. Here you don't have to really think about theoretically. Let's go to 7th question. 7th question is function or real number is related to real number. F of x is equal to 3 minus 4x. Any linear function will be 1 to 1, I have told you, and also on to, because we try to do this graph. X is 0, y is 3. In this, x is 1, y is minus 1. X is 1, y becomes minus 1. X is 2, y becomes minus 5. So some straight line like this. So any linear functions is 1 to 1 because every element on x will be uniquely related to a y value. Can you see? So then that shows that it's definitely 1 to 1 because every linear function is 1 to 1 and on to. From the graph itself you can see. So let's go to, because in this, you know, this is a real valued function. These are called real valued function where y is a subset of x. You've learned it in 11th standard. So that is clear. Okay, let's go to next. Let's go to next question, which is the 8th question. Oh, there's a second subdivision where on real number to real number, f of x is equal to 1 plus x square. It is a quadratic function. And this graph doesn't start with the origin. Okay, it is not like this. It's an upward parabola, right? But it is plus 1, so it has to be from here, from plus 1. The upward parabola has to be from there. So then negative values will also get mapped to positive y, and the positive values is also getting minus 2 is related to 4 plus 1, 5. A 2 is also related to 5, shows that it's definitely many to 1. Now all the negative elements, the real numbers on the y-axis, will not have a pre-image. You have to write all negative elements, and therefore it is not onto. Okay, these 7 sums that I have taught you last class, I hope you are all very clear with it.